we are going to discuss the problem count occurrences of a given word in a 2D array. So we have to find the number of occurrences of a given word in a 2D array of characters where word can go up, down, left, right and around 90-degree bends. So this is the problem. Let's take example and understand what the problem is saying. You can see that here in this case there are 4 rows and 5 columns in our matrix which is given to you, and the target string is snakes. You have to tell the number of occurrences of these snakes in this matrix. Now, if you will just observe this matrix, I will just copy it and let's discuss it in the whiteboard how we can just check the number of occurrences of this string snakes in this matrix. So this is the sample example given to us. Now you can see here that in this matrix we have to find for the word snakes. Okay, we have to find for the word snakes. Now you can see that the first letter of this snakes is S. So obviously we have to start from the S letter of this matrix. So first we will just iterate through this matrix and we will search for the word S because from there we have to start. You can see that this is the word S, which is the first word only. Now the question says us that you can either move up, right, down or left. This is how you can just move in this matrix, and by moving you have to create a word which is given to you. In this case it is snakes. You can see that if you will just move the right of S, you will get N, then the next target is A, then K, then S, then E, then S. Here the first snake you have got. Similarly, you can see here also snakes is there. And similarly, there is one more occurrence of this word snakes, which is like this, that you have to just move, which is also given to you like this. So these are some occurrences of snakes. So there are basically 3 occurrences of snakes in this example. So you have to check for each and every occurrence. Also, you have to check that no word should be repeated. So a word should not be repeated. For that also you have to make a check. For example, in this case, if the word should be, let's say that the word is not snakes, let's take a different word. Okay, so let's take that the word is, let's say, NaN. In case of NaN, we will start from a letter N only. Let's say this is a letter N. Then we have got A. Now we cannot just again go to N. That is not allowed. So for that also we have to make a check that no word should be repeated. So we will solve this problem in a recursive manner. So recursively what we will give? We will create a recursive function. Let's name it something like find word. This is the recursive function. And let's give it some parameters. Let's say the matrix which is given to us and the target string. That will be the obvious parameters for this function find word. That are the obvious parameters. Then we can give them the start index, which is I comma j. So I comma j should be the start index from where we are starting. Okay, and then we will give it a current index. Current index. So this current index will basically tell us the current position where we are at that target. So for example, if the string is snakes, so first we are starting from here, let's say. Okay, so we have got the first word is. Now we will search for the word N. And to search for the word N, we have 4 places. First is the right of S, below of S, bottom of S, left of S, and top of S. So we will call these 4 functions recursively with different value of I and j and current index. This is how we will basically focus. We will also have our base condition. The base condition is that when this current index will be equal to the size of our target, that means we have checked for each and every character of our target word. So in that case, what we will do? In that case, we can just simply return 1. And if the case is that this snakes, or you can say this word n, is not found, then we will return 0. For example, if we will consider this as a start, you can see that there is no n in any one of the 4 positions of this s. So we cannot create a word starting from this s. In that case, return will be 0. This is how we'll just create a recursive function. So I think that it is better to first write a code and then we will simultaneously understand how we are basically solving and implementing the logic which we have taught. So this is our code editor. Let's just move it there. Fine. So first what we will do, that let's create a recursive function and then we'll call that recursive function inside our the main function which we have to write. So let's name it like you can say find world. Okay, so let's name that function find world and we'll pass some index to it. Okay, so let's write it like we can just write int find world. Okay, and here we will first give it this vector which is the vector mat. This is the first thing we will just provide to this matrix. Okay, now means to this function. Okay, I will just give it simply. The next thing will be our target string, that will be also is very important to provide here. Okay, which we have to search basically. Then we will give index I and index j. They are basically the start index for that recursive approach. Then we will have a current index function that will point out to the current index in our target string, which we have to find. Now the base condition will be that if our value of I is less than 0 or our value of j is less than 0, okay, or there can be another thing that a value of I is greater than mat dot size, or our value of j is greater than, or let's say equal to also. Equal to is also not a case, not a fine case, or it should be less than. So if it is greater than what mat, and let's say the start index dot size. Okay, if this is the case, then we can simply write that we have to just return 0. We have to just return 0. Okay, now this is the base case of our recursive function. Now we can also just focus on that what is the current character which we are currently in that matrix. So our current character, let's say current character is equal to matrix I comma j. This is our current character. Now our current index in this target is this current index. So we want that our current character should equal to the character where our current index is currently pointing. So if target current index is equal to current character, or let's write a non-basic case if it is not equal to, okay, to current character. In that case we can just return 0. Okay, and if it is equal to, then what we will do, then we will recursively call the function for the next character. Okay, but there is one more case, that is the successful case, that if we have reached the last index of our string, means if our current index is equal to target.size, that means we have checked for each and every character and we have just written 1. Okay, this is the case. Now if these both cases are failed, that means our current character is equal to the current index. Now we have to recursively call for the next index, means current index plus 1, and in the 4 directions. So we will call for the 4 directions, okay, and that value will be stored in a character, let's say in a count variable. Let's take a count is equal to 0 currently. Okay, now first let's call for the up, or let's say yes, the position which is up of that I comma j. So for up of I comma j, it will be something like I minus 1 comma j. So now we will call for I minus 1 comma j. Okay, so I will just again write this thing. Find word, mat will be same, target will be same, I will be I minus 1, j will be same, and current index will be current index plus 1. Okay, similarly we will just find for all the other. Let's take down first. So for down it will be I plus 1 comma j. Okay, so if I will just write this thing, so you can see that I will just make it I plus 1. Similarly, let's take for right, which is something of I comma j plus 1. So let's just paste it and let's make it I comma j plus 1. And similarly, we will call it recursively for left, I comma j minus 1, and that will be again just recursively call it, it will be I comma j minus 1. This will be our approach. This should be our approach. Now what we will do, we will just return, and because these all the function will give us some value because the data type is int, so we'll just store that value in our count variable. That is why our count was created. So we will just make it everywhere count plus is equal to whatever it is returning, and then we'll just return our count. That will tell that if a word, or you can say how many words are possible from a basically an index. It's just like a brute force recursive approach. Now we have to make one more surety, that is to avoid taking an index repetitively, means multiple times. Just like I've told you that if the example is nan, if the example is nan, then there is a possible case that first we'll start from here, this n, then move to a, and then again this n can become. So what we will do that in place of this n, we'll just make it a blank, let's say /0. That will make that this n has been visited. To make a node visited, we can either use a visited matrix, but here we'll just use the concept of this. So in that case, what we can do, we'll just change the value of our matrix I comma j. We'll just change it, and we will change it to blank, okay, so that it should not be checked. And again after it, we'll again change it to the original character, which was current character, which we have already stored, saved. This is how the thing will look like. Okay, now we have to just recursively, we have to just call this function, but we have to call this function for each and every index. So if you will just see here, there are some n into m characters in this matrix, and we have to call for each and every character. We have to call this function considering each and every character as the start index. We will also consider this k as the start index, and this each and every character, because we don't know that from where the string is, the word is possible. It is not given that a word is only always possible from 0, 0. It can be possible from here, it can be possible from here, from anywhere the word can be possible. So what we will do here is that we will just create another function that, so in our main function we will take a value int count. In this we will just count the values, and we will take two for loops. Okay, so here n is basically, you can say, matrix dot size. Okay, okay, fine, fine, just a minute, like this. And here we can write matrix dot size, or we can say matrix dot I size. That will be more perfectly. Okay, and then it will be j plus plus. Then for each and every value of I comma j, we will call this function find word. In this we will give mat target I comma j comma 0, because for each and every index we will consider this current index to be 0, means we will start from the start of our target string, and then we'll just count it, store it in our count variable, and then at the last we'll just return. Okay, so let's check it. Let's compile this code, how it is working. So yeah, it will work fine for our sample test case. Let's submit it. So yeah, we have got some wrong answer. Okay, so for 4 and 1, we have got our wrong answer. So it was like that when it was 4 and 1, so our answer has got wrong. So let's see that what we have done wrong. Okay, so what we are doing here, we are making some mistake. Okay, so the case was that when our length of our row was 4, okay, and the length of our column means there are 4 rows and 1 column, then our answer is getting wrong. Okay, so we have to just make a check on that why it is doing that. So the thing which we are probably missing is that here we have to check that when our current index will be equal to target dot size minus 1, then also it's written 1. Why? Because if it has reached the last index and we have got, then also it should be right. So now it should give the right answer. That was a mistake from my side. Yeah. Now you can see that all the test cases are passed. Now, if we talk about the time complexity and space complexity, so we have not used any extra space. Yeah, there will be some space for this recursion stack, but overall our space complexity is just O of 1. If we talk about the time complexity, so it is quite complex. You can see here that what we are doing is that first in this function we are just taking two nested loops. It will be something like, you can just write, it will be something like O of n into m, where let's take that n are the number of rows and number of columns, and in each we are basically calling for this function recursively. We are basically calling this function recursively. Okay, so you can see that this recursion will take that for each recursive function there are 4 recursion called. Okay, and it has been done length times. Overall, it will be something like 2 to the power length of the string. It will be like 2 to the power length of the string, and this will be the time complexity. It is quite complex and is in our brute force approach. I hope this video is clear to you. If it is clear, please hit a like button, subscribe to the channel, comment, and share it with your friends. Thank you.